Welcome to my YouTube channel. Today we'll be discussing about relation and function. Right, before we dive into calculation, let's just do a little discussion about what this means. In mathematics, we study relation between two sets of numbers where members of one set are related to the other set by a rule. We're going to discuss about this rule. Rule means equation, what relates one set of numbers to another set of numbers. So relation is also known as mapping. Yeah. Some textbooks you're going to see mapping, some textbooks you're going to see relation. They are all the same thing. Okay, now looking at this number, we are saying in this set X, we have 7, 8, 9, 10, 11. They are all linked with certain numbers in the Y, which is 15, 17, 19, 21, and then 23. We need to take note of the arrow. This is the input, this is the output. So the arrow actually shows the direction from the input to the output. Now looking at this, when we talk about the rule, you are going to find out that they are following a sequence. We've seen 7, we've seen 15. We've seen 8, we've seen 17. We've seen 9, we've seen 19. So this suggests that every of this value in x is actually doubled plus 1. That's 2 multiplied by 7 is 14 plus 1, 15. 8 multiplied by 2 is 16 plus 1, 17. 9 multiplied by 2 is 18 and plus 1, 19. 10 multiplied by 2 is 20 plus 1 is 21. 11 multiplied by 2 is 22 plus 1, 23. So now this is the rule. We're going to discuss about this in the later part of this video. All right, a relation exists between two sets of numbers if we can find a rule that maps member of the first set called domain. Remember I called this the input. It can also be called the domain onto the member of the second set, that's this Y, which is called the codomain. The rule must hold for all possible pairs that are connected, so that when we select a value of x, also called an input, and apply to the rule of the relation, we obtain the y value, also called the output. We can also refer to y value as the image of x value. What this is trying to say is, whatever rule you're trying to implement for one value, you should actually go for the remaining. Someone can say 7 plus 8 is actually 15, but try the next value. 8 plus 8 is 16, which is not 17. So that rule does not stand. Whatever you do for one value in the hex, in the domain, to give the domain, must go for all the values there. And we're told that every value in y is an image of the value in x. All right, let's proceed. Condition that must be present when a relation exists. All right, let's look at it. Two sets are involved, that's x and y. Discussed about that. There must be a clear rule describing the relation, like in this diagram, this arrow diagram. you see that the rule that applies to it is actually 2x plus 1. There is a direction properties, that is, the relation is defined from one set called the domain onto another set called the codomain. We've explained all this. So let's proceed. All right, let's assume we define a relationship for the set X to be 1, 2, 3, 4 to the set Y, which is 2, 3, 4, 5, 6, 7, 8. All right, so we'll find the relation as, okay, let's look at it. We have one is having an image of 2, 2 is having an image of 4, 3 is having an image of 6, 4 is having an image of 8. So you can see that each of the value of x of the inputs are double to get the image or the codomain as that result. All right, now if you notice, sorry about that, if you notice this, you're going to see some values in the codomain having nothing linked from the input, such numbers as 3, 5, and 7. All right, now this one, right now we're discussing about range. We want to see what range is all about. All right, the subset of y consists of even numbers 2, 4, 6, 8. They are called the range. So, in other words, range are those image gotten from the input. It must be linked with something from the input. So that's our we'll call range. The entire set of y, everything is y. All the numbers there are called the codomain. So now this is the definition of range. All right. The range is defined as those members of the codomain that are used. That is, they are connected to some members of the domain by the rule that defines the relation. They are also the output values or the image of the input values. We'll discuss about all this. The first diagram shows the range. Okay, shows that the range is equal to the codomain. Let's look at the first diagram. Can you see that every value in the domain is linked to a codomain? So it means every value in the codomain actually has a domain. It means, in other words, we can say every domain has an image. All right. So, and if that is the case, it means that the range is equal to the codomain. But if it's not so, it means that the range is a subset of the codomain. So I want you to try this and leave your answer at the comment side below, and then I'm going to comment if it's actually correct. Right, let's look at types of relation. We have one-to-one mapping, we have one-to-many mapping, we have many-to-one mapping, and then we have many-to-many mapping. Let's consider the first one-to-one mapping. Okay, it is a relation if no two elements of the domain have the same image in the codomain. One-to-one mapping does, in other words, one domain to one codomain. One to one. Let's say, let's give a practical example. A footballer to one number. You can't find two footballers in the same team having, let's say, the number 10. No, it's not possible. So, it's not possible. A player to the jersey number 10, the goalkeeper to number 1. Another player cannot be wearing number 1 in the same team. So that's 1-to-1 mapping. All right. The second is one to many mapping. A relation is one to many if an element of the domain is mapped onto more than one element of the codomain. Example here, 4, and then we have 2 and -2, and then we have 9, we have -3 and 3. So technically what we're trying to say is the square root of 4 is either 2 or -2. So this is one to many. This is one to many. One to many. You get? So we can say, let's see, let's give practical examples. Let's say a state, a country to many states. For instance, Nigeria has 36 states. Another nation has other states, a number of states. So one to many. All right, let's look at many to one mapping. A relation is many to one if two or more elements of the domain have the same image in the core domain. It's actually the reverse of one to many. You can look at it. 1 and 2 are all linked to D. 3 linked to E. 4 and 5 is linked to F. Right, so the last one is many to many mapping. If a relation has both one to many and many to one association, then the relation is said to be many to many mapping. So that's all containing types of relation. Right, let's look at function. Function is a relation that asks exactly what happens for each input in the domain. Right, let's look at the three characteristics containing function defined from a set X to a set Y. Every member of X is mapped onto one and only one member of Y. An input cannot have more than one output. Two or more members of the set X can be mapped onto the same member of the set Y. All right, let's. I think it's looking like too much English, right? Okay, let's give a practical example concerning function. Function is actually close to a relation, but it has a slight different. Now let's look at in the real world. We may think of a function as a mapping onto a set of x. Let's say set x. Let's assume set x are sons, and then set y are biological mother. Now, each son will be associated with one and only one mom. That's the first instance. The second instance, two or more sons can be associated with the same mother. A, a mother, a woman, can give birth to more than one son, right? Remember, X is for son, Y is for mothers. Now, the third one is this. A son cannot be associated to two biological mother. It's not possible. So for every case like that, we don't consider it as function. Let's look at this five diagram and then look at those which are function and those ones in which they are not function. All right, the first one, we have one link to D, two link to B, three link to C, four links to A. This is a one-to-one function, and the range is the same as the codomain. The second, this is a one-to-one function. Somebody will be like, okay, 2, 4, 6, and 15 are not having any uh, image. It is possible a woman can be barren and don't have a child. It's very possible. So this is actually a function. I will categorize this as a one-to-one function. The only difference between and the first one we discussed is this, the range is equal to the codomain, but this, the range is not equal to the codomain. So we say the range is a subset of the codomain. Let's look at the third one. Is that a function? Yes, that's a function. This is a many to one function. Let's say Mother Abigail gave birth to child one. Mrs. Beauty gave birth to 2 and 3. And C and D do not have a child. So we consider this as a mapping. Okay, to the fourth diagram. This is not a mapping. Let's look at it very carefully. 9 is trying to say his mother is 3 and minus 3. That is not possible. 4 is trying to say his mother is 2 and minus 2. That's not possible. And then 16 is trying to say his mother is 4 and minus 4. That's not possible. I hope you're understanding the logic of everything right now. Okay. So this looks like a one-to-one. This looks like a one-to-one. This looks as a many-to-one. This looks as a one-to-many. And that one-to-many relation cannot be considered as a function. All right, let's look at this. Mother Teresa is saying a child is 2. Mother Faith is trying to say a child is 5. And let's say Mother Naomi is trying to say a child is 9. But now 7 is saying it does not have a mom. That's not possible. Someone must have given birth to 7. And because we can't find it in the codomain, we don't consider this as a function. All right, I hope I've been able to explain very, very detailed about mapping and function. Now let's go to the calculation.